Hello students, in this video we will be going to discussing about the time division multiplexing, also called as TDM. See the problem. It is a linked data question, the problem on TDM. What is the linked data? Read it. A CD recording system samples each of two stereo signals. How many signals are? Two stereo signals with a 16-bit A to D converter. 16-bit A to D converter at 44,100 samples per second. The bit stream is augmented by the addition of error correction bits, clock traction bits, display and control bits. These additional bits represent 100% of overload. Actually 16-bit A to D converter, another 16-bit we are using for error correction, display and control. The output bit rate of the CD recording system is option A 1.411 Mbps, option B 1.822 Mbps, option C 2.822 Mbps, option D 4.282 Mbps. Second question. The CD can record 1 hour worth of music. Okay. The number of bits recorded on a CD is option A 5.08 Mbps, option B 5.08 Gbps, option C 10.16 Gbps, option D 20.32 Gbps, gigabits. What is the first question they are asking, sir? Bit rate, sir. What is the bitrate formula? RB equal to capital N small n into Fs. What is the capital N? 2 into small n. There are total 32 you need to take into 44,100. Why 32? 16 for A to D converter. Another 16 we are using for additional bits for clock extraction, display, all those. Calculate, sir, you will get 2.822 Mbps you will get. What is Mbps? Means megabits per second. But the same thing he recorded for 1 hour. Recorded for 1 hour. So what is the total number of bits per 1 hour? These bits are per second. 1 hour means 60 minutes. Each minute of 60 seconds. Calculate, you will get a 10.16 Gbps you will get. GBP, gigabits, that's it. Gigabits, these many bits, not per second. This is per hour. These many bits will be recorded. Because for each second, 2.822 per 1 hour means 1 hour is having 60 minutes into 60 seconds. Each second 2.822 Mbps means into 10 power 6. Don't forget that. A simple problem on the bit rate only. Clear? See the problem. A signal is band limited to 3.6 kHz and 3 other signals are band limited to 1.2 kilo each. So total how many signals? 4. These signals are to be transmitted by means of TDM, time division multiplexing. If each signal is sampled at its Nyquist rate, then the speed of the commutator by assuming 6 samples per second. Option A 864,000 rotations per minute RPM. Option B 144,000 RPM. Option C 86,400 RPM, 14,400 RPM. All options are closely is there. It's a small mistake will make a wrong thing here. Anyhow, first thing you need to understand, there are 4 signals are there. If we take the commutator, but for the first one, we are using 3 because this is 3.6. So, and the remaining 3 is 1.2, 1.2. if I take the fs value is 1.2 as a reference, 2 into 1.2k, so 2.4k. First one at least I need to maintain 7.2, at least double that. So here 2.4, 2.4, 2.4, 7.2. Next, for second signal, 1 is sufficient. Third signal also 1 sufficient. Fourth signal also 1 sufficient. So total you will get 6 samples you can see. First I will calculate RB. From there you can get the number of rotations. What is RB, sir? Bit rate. Means number of bits per second. Coming to the bit rate RB, there are total 6 samples are coming in each rotation. So capital N value 6. Small n is not mentioned, means let's take 1 into Fs. What is the Fs, sir? 2.4 I am maintaining. Are you getting my point? Then 2.4k. Let's see. 6 2s are 12. This is 2.4. So 14.4 kbps, sir. This is what RB value. kbps. But here what is asking? Rotations per minute. Try to see. First what I will do is this RB value I will calculate. This is 1000 now. So another 2 zeros will come because 14.4 per minute. RPM is given per minute, means into 60. Now this is about RB. These are the bits per second. Now, per minute. That is second per minute. This is. But he is not asking the number of bits. He is asking rotations. In each and every rotation, 6 bits are going on. 6 bits are going on. So total how many rotations will come? The number of rotations is nothing but this divided by 6 I have to make. Because in each and every rotation, 6 bits are taking. 6 samples are taking. So this will becoming as a 10. Then it will be 144. Another 0. This will be what? Rotations per minute. You can see the options. If you are seeing the options, then which option will be the correct? 144 000. So option B. If you mistake in this and if you multiply, first option will come. That is the logic there. So first I calculate the number of bits per minute, and each and every rotation 6 samples are taking. So I divided by 6. So total you will get the number of rotations. Are you getting my point? See the next problem. The outputs of 18 members of 20H low pass filters are sampled, multiplexed and A to D converted. If the sampling is at the Nyquist rate of 40 samples per second corresponding to signal of 20H bandwidth already given. And if we use 3 bit per sample, small n value, to represent each voltage sample, bit rate is option A 1.9 into 10 cube bits per sample, option B 19 into 10 cube bit per sample, option C 2.16 into 10 cube bit per sample, option D 21.6 into 10 cube bit per sample. Follow. What is asking, sir? Bit rate. What is the formula? RB equal to capital N small n into Fs. Here how many members? That is nothing but signals. That is 18. What is the small n value given? 3. And this value given 40. Then how much it will comes? 40, not K, 40 only. Calculate, you will get 2160 you will get. If you see the options, yeah, you can write this as 2.16 into 10 cube you can write. Anyhow, what is the units for RB? Bit per second only. If you see the options, yeah, this one, try to see. Both are just a point difference. Don't go for the mistake. So simple question on the TDM by calculation of RB. That's it. Clear? Yeah. See the next problem. Consider the following statements regarding time division multiplexing, that is TDM. First, the information from different measuring points is transmitted serially on the same communication channel. Yes. What is the TDM? Commutator I told, parallel to serial data. And the same communication channel. Yes. It involves transmission of data samples rather than continuous data transmission. In TDM, what we are transmitting? Samples only. Third, it is especially useful when telemetry fast changing and high bandwidth data. In FDM, bandwidth sharing will be there, FDM. But in TDM, no sharing of bandwidth, higher bandwidth. So all the three statements are correct only. What is going? Which of the following above statements are valid in respect to TDM? We already discussed it. All the three are correct only. So remember another 3 points about TDM. This point, first point, we already seen. Commutator having many inputs, one output, parallel to serial data and common channel. We are sending sample rather than continuous. Is useful for high bandwidth. Yes, all the three are correct. See the next problem. In synchronous TDM, there are 4 inputs and the data rate of each input, each is given 3K. There are 4 inputs, each is 3K. If 1 bit at a time is multiplexed, what is the duration of each frame? Option A 0.02 millisecond, option B 0.03 millisecond, option C 0.33 millisecond, option D 0.22 millisecond. What is asking duration of each frame? What is the duration of frame? TS. He is given that each data rate is 3 kbps. So total data rate RB value will be, there are 4 messages, each of 3K, then it will be 12K. What about the TB value, sir? 1 by RB, sir. That is 1 by 12K. What is TS equal to? Here, if 1 bit at a time is multiplexing, one bit only taking. Total how many inputs are there? 4 inputs are there. In each one how many we are taking? 1 we are taking. So 4 messages in each 1 bit we are taking. Each bit duration is 12K. K means obviously millisecond. 4 ones, 4 threes, 1 by 3. 1 by 3 means 0.33 we already know. 1 by 3 means 0.33. Now you can see option C is the correct answer. This is also the previously ESC problem only. One of the different question asking the calculation of the time duration of each frame, which is nothing but TS. Clear? See the next problem. A TDM system is to be designed to multiplex the following signals. X1 equal to 5 cos 2000 pi t, X2 equal to 2 cos 2000 pi t into cos 3000 pi t. The minimum sampling rate is option A 4K, option B 5K, option C 10K, option D 6K. Here what is the frequency? You will get 1000. But here see there is a multiplication. Whenever there is a multiplication, cos A cos B formula apply. Cos A plus B, cos A minus B. What is A plus B means? You will get a 5000. A minus B means 1000. Reference is we will take highest frequency. 5000 pi t means what is the maximum value you will get? 2500. 2500. Then what is the Nyquist rate? Sorry, then what is the sampling rate? Fs is minimum is Nyquist rate. That is 2 times F max. Then how much it is? 5K. So option B is the correct one. Clear? See the next problem. It is a assertion reason type of question. Assertion given TDM can be employed to transmit signals having unequal bandwidth. Reason, if sampling theorem is strictly followed, any analog signal can be reconstructed from its samples. We already know options are option A, assertion, reason, both are correct, and reason is correct explanation for assertion. Option B, assertion, reason, both are correct. Reason is not a correct explanation for assertion. Option C, assertion is correct, reason is wrong. Option D, assertion is wrong, reason is correct. First, see the both statements individually. TDM can be employed to transmit signals having unequal bandwidth. Yes, in the TDM I shown. In this situation, to get minimum bitrate, what I told, take the minimum value. If any signal is more, like you can take the more channels. So TDM can be employed to transmit signals having unequal bandwidth. Correct. Second one. What is the second one? Sampling theorem statement only. If sampling theorem is strictly followed, any analog signal can be reconstructed from its samples. Yes. Now see. TDM can be employed to transmit signals having unequal bandwidth because if sampling theorem is strictly followed, any analog signal can be reconstructed from its samples. Use the word because in between. It's looking like a meaningful one. TDM is using for is employed. We take in TDM for signal transmission of unequal bandwidth because sampling theorem is following. It's not looking like a formal statement. So I can go with the option B. When both are correct only, then the situation comes across. So you can use the word because, then you will get, if you are feeling meaningful, go with A, not go with B. Clear? See the problem. 4 signals G1 of T, G2 of T, G3 of T and G4 of T are to be multiplexed and transmitted. G1 of T and G2 of T have bandwidth of 4K and the remaining 2 signals have bandwidth of 8K. Each sample requires 8 bits for encoding. What is the minimum transmission bit rate of the system? What is the formula for bit rate, sir? RB equal to capital N small n into Fs, but signals having different bandwidths. So small n into Fs1, Fs2, Fs3, Fs4. Or you can take the channel like that also. You can calculate by taking the commutator in the second, by considering the lower bandwidth is a reference. Each sample required 8 bit. So small n value 8. Fs1. This is having 4K. 2 times 4K. That can be write directly. 2 times 4K means 2 4s are 8K. Second one also 2 4s are 8K. Third is 8. So 16K because sampling rate is Nyquist rate. 2 8s are 16K. Calculate, student, you will get 384 kbps. 384 kbps means option D. Whenever signals having different bandwidth, use this formula, then you will make it. If small n is not mentioned, take minimum number 1. If given, take. If any condition is given, from there calculate. Yeah. See the next problem. In asynchronous TDM, asynchronous, for n signal sources, how many signal sources? N. For n signal sources, each frame contains m slots, where m is usually option A less than n, option B 2n, option C n greater than 2n. Unlike the synchronous TDM, in asynchronous TDM what is happening is, if any source is having data, that is only connected. If source is not having data, that is not connected to the slot. But synchronous are connected. But in asynchronous, only source having the data that is connected. So generally in asynchronous, that n value, this n value will be, m value will be generally less than the source, because all sources may or may not have the data. So in asynchronous, m value generally less than the number of sources. Option A, one of the good problem that is on theory. See the next problem. In a certain 12-channel TDM system, it is found that channel number 3 and channel number 8 are connected to the same input signal. This technique. Option A weighs the channel capacity. Option B takes care of the different sampling rates. Option C is required when different bandwidth signals are to be transmitted. Option D reduces noise. When you see this type of situation, for a same input is connected to two channels, when are two slots. When in the TDM I given, whenever we are taking the sampling rate reference as a minimum one. What is that? For example, 600, 600, 1200 is there. So I take in a sampling rate reference as the minimum value, that is 1200. Then for the first one, 1200 sufficient, second one also sufficient. But for third input, minimum is 2400, 2400. So two are connected. Here also number 3, number 8 connected for the same input. Why? Because when signals are having different bandwidths has to be transmitted. One of the excellent problem asking in the ES examination. So option C. Because of that, what will happen? Bitrate will decrease. See the next bit. A TDM link has 20 signal channels, and each channel is sampled 8000 times. Each sample is represented by 7 binary bits and contains an additional bit. Each sample is represented by 7 binary and contains an additional bit for synchronization. Are you getting my point? So each sample having one synchronization bit. Try to concentrate. The total bit rate of the TDM link 1180 kbps, 1280 kbps, 1180 Mbps, 1280 Mbps. What is the formula for bitrate, sir? Bitrate RB equal to capital N into small n plus B into Fs I given. What is this B? Number of synchronization bits per sample. If it is per frame, capital N small n plus A. Try to understand. That also will take weight. What is the capital N? How many signals? 20. Small n value 7. Synchronization bits 1 into Fs. Fs is given 8K. 7 plus 1 8. 8 8 64. 64 into 2 128. 0 is there. K is there. So option B is the correct one. The same problem will be if they are giving us a synchronization bit per sample. Sorry, per sample is given, per frame. Then what is the formula? RB equal to capital N into small n plus A into Fs. A indicates number of synchronization bits per frame. This is per sample. See the difference. Clear? See the next problem. A comparison of frequency division and time division multiplexing system shows that option A, FDM requires lower bandwidth, but TDM has greater noise humidity. Option B, FDM has greater noise humidity and require lower bandwidth than TDM. Option C, FDM requires channel synchronization while TDM has greater noise humidity. Option D, FDM requires more multiplexing while TDM requires band pass filter. Just see which is having more noise immunity? Obviously TDM, because it is a digital technique. We are having regenerative repeaters. So if you see the first statement, TDM has greater noise immunity. Okay, I can go with the option A because FDM needs the lower bandwidth when compared to the TDM. Let me analyze the remaining also. Option B, FDM has greater noise immunity, is a blunder. TDM having greater noise immunity. FDM requires channel synchronization, no. FDM requires multiplexing. TDM requires band pass filter, no. TDM we are having low pass filters as well as commutator, decommutator. So if you see all the options, obviously option A is more suitable. Clear?